Okay, the imaginary number I. Mathematicians for years have invented numbers and systems to help them solve problems throughout history. For example, if you just take this simple equation, x plus 3 equals 2, we know how to solve that by subtracting 3 to both sides, and now we get negative 1. In the number system, in the beginning, there were not any negative numbers. And then mathematicians said, hey, we can use that number and work with it, and so carried on. And then mathematicians started dealing with things like this. If x squared equals 2, what does x equal? Well, square root of 2. And if you get the decimal for that, you figure out quickly that it's an irrational number. It doesn't come out to a specific fractional number or a number that we can definitely say it is exactly this number. So then here comes this equation here, x squared equals negative 1. How do you solve that? Well, if you take the square root of it, you get x equals the square root of negative 1, and you can't really even get an answer for that. So we defined that as an imaginary number. So the imaginary number I stands for square root of negative 1. And we're going to start using that. Now, some cautions using that. When you're dealing with radicals, especially, imaginary numbers or negative numbers under a radical sign. When you see a negative number under a radical sign, stop for a moment and think. You can't work that number until you change it into a number in the imaginary number system, and then you can use it. For example, let's take square root of 4 times square root of 25. In the regular square root system, we could do 4 times 25 is 100. Square root of 100 is 10. I could also do the square root of 4, which is 2, the square root of 25, which is 5, and I get 10. When you're dealing with imaginary numbers, square root of negative 4 times the square root of negative 25. The first step has to be, you cannot multiply negative 4 times negative 25 and get positive 100 and say the answer is 10. When you have a negative under a radical, the first step has to be change it into an imaginary number and then work the answer in the imaginary number system. So this becomes I times root 4. This becomes I times root 25. And then I can multiply, or I can do the radical part first. I could say this is 2i. This is 5i, and 2i times 5i is 10i squared. And what is I squared? Oh boy, we need some more definitions here. All right, so I want you to look at the pattern in terms of exponents of I. So we'll do a few of these. I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th, and let's do I to the 50th. Okay, so I squared, root negative 1 times root negative 1, how about negative 1? I to the 3rd. I like to do them in patterns using I squared. So this is I squared times I. I squared is negative 1, so negative I. I to the 4th. I squared times I squared. What do you think that is? I squared is negative 1. Negative 1 times negative 1? 1. Positive 1. All right. I to the 5th would be I squared times I. These become a 1. So 1 times I is I. So you see the pattern. It's I is I. I squared to negative 1. Instead of writing that, we call it I. So it's I, negative 1, negative I, 1. And we start back at I. So what do you think square I to the 6th is? Negative 1. What do you think I to the 7th is? Negative I. What about I to the 8th? 1. And again, if you want to figure it out, you can figure out the I squareds. I to the 8 is I squared times I squared times I squared times I squared, right? Each I squared is a negative 1, positive 1. I to the 50th. I like to put them in patterns of I squared if I can. How about I squared to the 25th? It's 2 times 25 is 50. And what is I squared? Negative 1. So, negative 1 to the 25th, negative 1. So, working with the i's is not so bad. And down here, so 10 I squared becomes negative 10, because I squared is negative 1. So that's kind of the most important one. I squared is negative 1. But you might want to have a note card of the first 4. And then you can do patterns from there. I usually just do patterns with the I squared. Whatever works. All right, let's do a little simplifying involving some imaginary numbers. All right, right here, 2 radicals, easy to multiply. But first I have to know that this has to become an imaginary number. And then I can take the square root of 16, so I can do 4i. This one, 7i. Now I can multiply. 4 times 7, 28 I squared, right? And what is I squared? Negative 1. So, negative 28 is the answer. All right, suppose I had something like this as an addition problem. Square root negative 16 plus square root negative 49. This becomes 4i plus 7i, 11i. And that's the answer. Can't do any more. You can leave an I in the answer. You cannot leave any other exponent of I. So you need to use that pattern of numbers. The easiest way is put them in terms of I squared. Okay. This one looks pretty easy. The directions are simplify. You can't have an I in the bottom of a fraction because it's a radical. So multiply the top and the bottom by I. So I get 2i over 3i squared. I squared is negative 1, so 2i over negative 3, or negative 2i over 3. Either one of those is an okay answer. All right, next one. Change it into imaginary first, so 6 over I root 2. 2 problems. Can't have an I in the bottom, can't have a root 2 in the bottom. So multiply by I root 2 over I root 2. All right, so you get on the top 6i root 2. On the bottom, you get 2i squared. Now be careful here, don't reduce the i's too quickly. If you get an I squared, that's always a good thing because that's a negative. So I have 6i root 2 over negative 2. I can divide the 2 into the 6. So what do I get? Negative 3i root 2. And that is the answer. So good luck with the